The US has no operational or defensive hypersonic missiles to work against it, while its competitors use advanced hypersonic weapons. After registering success in hypersonic weapons testing, it is now pursuing space-based systems to combat threats from hard-to-trace enemy missiles. To that end, 2 new contracts for a constellation of missile surveillance satellites were announced by the U.S. Space Development Agency, SDA. The satellites will track and monitor China and Russia hypersonic missiles. The contracts were awarded to L3 Harris and Northrop Grumman on July 18 for a total cost of $1.3 billion. An advanced satellite system, a capability neither China nor Russia has, will be launched into space by 2025. According to a press release from SDA, each company will build 14 satellites as part of the Other Transaction Authority's (OTA) contract. L3 Harris received 1 award, with a possible value of nearly $700 million, and Northrop Grumman received another award, with a potential value of approximately $617 million. MDA plans to develop a layered defense system that integrates ground-based radar, satellite-based sensors, and other military weapons systems into a single network to locate, track, and potentially intercept and destroy hypersonic targets. In February 2022, SDA announced the award of 3 prototype contracts totaling approximately $1.8 billion for a mesh network of 126 optically interconnected space vehicles, SVs. The goal is to deliver a reliable, low-latency, high-volume data transport communication system that is ready to launch from September 2024. Based on this concept, 28 small satellites will be launched by SDA into low Earth orbit. The satellites are intended to provide early missile warning/missile tracking capabilities of the National Defense Space Architecture or NDSA in the future. Hypersonic missiles can travel up to 6,200 km per hour, or more than 5 times the speed of sound, in the upper atmosphere and can fly 100 feet over the ocean without being seen. Due to their distinctive flight characteristics, boost glide vehicles are significantly more challenging to track than other weapons such as ballistic missiles. The vehicle is launched into the atmosphere after being propelled by a rocket at the required speed and altitude. The Constellation Space-Based Infrared System, SPIRS, which has a relatively small number of larger satellites, provides the U.S. military with existing capabilities for space-based early warning. However, it only works for conventional ballistic missiles, not hypersonic weapons. U.S., Russian and Chinese adversaries are using advanced hypersonic weapons. While China carried out tests in which its weapons spread across the globe, Russia has used hypersonic weapons against Ukraine in the ongoing conflict. Therefore, the need to intercept, track, monitor and kill these missiles is urgent. The National Defense Space Architecture consists of 2 tiers of space-based platforms known as the transport layer and the tracking layer. 2 sets of satellites will be present, one in an intermediate orbit of about 10,000 to 20,000 kilometers, offering a stronger presence, and the other in a lower orbit of about 1,000 kilometers. With the entire constellation, at least 2 satellites will be visible at 95% of Earth's locations at all times, and at least 1 satellite will be visible at 99% of Earth's locations. The tracking layer will provide advanced missile threat indicators worldwide, including hypersonic missile systems and warning, tracking and targeting information. This capacity includes algorithms, state-of-the-art processing techniques, aggregation of data across sensors and orbital regimes, and tactical data products that can be delivered to the right users.